This problem is actually exactly like the problems on the last test. They give you the velocity. So the first thing I note is that if I integrate the velocity, let's see, the time period of interest here is time 0 to time 1. Velocity formula, so if I integrate the velocity, one person raise your hand. Come on, tell me. If I integrate the velocity from time 0 to time 1, I'm going to get some number. What's I going to represent? Nice. Change of position for that time period. So I'll find the change of position for t equals 0 to t equal 1. Question. Once I know that change of position, I simply need to combine that with the fact that at time equal 0, the particle is already at 2, and then I'll know the new position. So my thought is, let's go find the velocity's integral. So it goes 0 to 1, 3t squared plus 6t dt. I need to do the integral without my calculator. So the first word I want you to say as a class, please, is if I'm looking at an integral without my calculator, what's the first word you should think of? Say it. Antiderivative. Antiderivative. So someone please hand find that antiderivative. Deborah's got it as well. Let's go, Ellie.
So the abstract, when you separate them by the antiderivative of 0 to 1.
Well, I'm going to skip writing it, but you're perfect.
Okay.
Perfect. So she's mentally splitting these apart. Keep going.
Okay, so then you take out the 3 to the constant rule, and you're going to do 3 to the third, or t to the third, divided by 3, plus 6, and t squared over 2.
Pause right there. Take it for Ellie. Okay, the first step in doing the integral is to find the antiderivative. Okay, I want everyone's eyes on the board. Don't put an integral sign here. Okay, we've already done half of what the integral requires, so we don't want an integral sign here. But we do need another symbol on this line. Everyone knows. Kelsey?
The line and then
Bar is fine. Perfect.
Yeah, bar
Perfect.
and 0, 1.
So take it for Deborah and Kelsey. You have a question? Please.
That means like you're plugging in like 0 for the t's and then 1 for the t's. Is that what that? Okay.
Just make sure you get the order correct.
Yeah.
So plug in 1 first, subtract, plug in 0. Perfect. Take it for Brady. Everybody good? Please.
Sometimes like it's not just gonna be really good, but like does it make a difference whether you put the parentheses like outside of the 1 and 0? Like
Oh, I know what you're talking about.
Because like sometimes you've done either and make a difference really, or
What you have to indicate is what does the 1 and 0 apply to. And in this situation, I've got to make sure that I know that the 1 and 0 applies to not only this, but also this. You stay with me, Ty. It's a really good question. So, for example, if I took away this parenthesis, this one here, the bar would really only apply to this. So I can't have that situation. So I add the parenthesis back. The one you're remembering looked like this. Some previous problem, it may have been like 3 parenthesis x squared over 2 bar, like maybe 2 to 5 or something, close parenthesis. So the reason I wrote it this way is because I want to do the bar to this, and then when I'm done, multiply by 3. That's all. I don't have to do it that way. I could actually take the parentheses off. It works either way. Ellie?
So when you're taking the antiderivative of the velocity, right when you start taking the antiderivative, so the second line, so what I did, that then you would start doing the position.
This is the position formula.
Yeah.
Right here. It doesn't have the plus c because we know it's going to subtract away anyway.
So in your line of, say like it took more than 1 instead to do that, then right as you start doing it, you don't do the...
Correct. Once you've taken care of finding the antiderivative, the the antiderivative of the velocity is the formula for position, for sure. Sarah, please.
How come on the second one you took out the 3, but not the 6?
Gotcha. We really did in both cases. We didn't factor anything out, we just did it all mentally. We said there are two things being added, so we can find the antiderivatives separately. Because 3 is a multiplying constant, we don't really worry about it, we just write it down. And then the antiderivative of t squared would be t cubed over 3. Next term. The 6 is again a multiplying constant, so I just wrote it down. And then I have t squared over 2. The fact that it looks like the 3 is outside doesn't matter. It's the same thing. Okay? Please, Haley.
If you're doing this on FR2, do you have to write like the bar 1, 0, or can you just like go down and plug it in? Because you have to actually.
If you skip writing the bar, it's okay.
Okay.
Yeah, if you just go from right there to plugging in, no problem. Okay? Anybody else? Good. So let's ask a question now. We've got to this point. I can keep going if you feel like it's helpful, but I don't want to do a bunch of stuff that you find boring. So just, you don't have to tell the whole world, but just kind of wave if you want me to keep going. Otherwise, we'll just call it quits. Okay, so keep going here for a second. So let's go over here. Well, yeah. So I start plugging in. You do the simple things first. 3 divides with 3 to make 1. 6 divided with 2 to make 3. So I end up with 1 cubed plus 3 multiplied by 1 squared minus, I kind of ran out of room here, need a big parenthesis. Oh, this one's easy. 0 cubed plus 3 times 0 squared. So all of this became 0. 1 squared is 1, this is just 4. Questions so far? Please.
Does it matter if you, when you wrote the integral itself, if you put 2 plus that, or if you just put to the end of, like, the possible?
Say it again, I'm not sure.
So how it's at t equals 0, x equals 2. If you add 2 to the beginning,
Oh, gotcha.
it, or
Yeah,
at the
good,
end
good.
when you come.
Doesn't really matter where, as long as I don't forget. And that's actually what I was going to ask next. So what does the 4 represent? Change of position between time 0 and 1. It's not the position. They want to know where is the particle at time equal 1. So where was the particle at time equals 0? 2. From time 0 to 1, the particle's position became 4 more to the right. So now where is the particle? Okay. Questions? Give me 1 or 2 if the board makes sense. 1 or 2 if the board makes perfect sense. Take it further. You know, let's bring a different question. Ellen, 4. Okay, so it said area. It said the area bounded by, or the region between, they give a graph. Kind of ignore the graph temporarily because it's the hardest thing to interpret. It says the x-axis. That's easy to understand, so I drew an x-axis. X equal 1, that's easy to understand. I drew a line, x equal 1. X equal 2. The last step is understanding the function. The key thing about the function is, I noticed that between x equal 1 and x equal 2, that function's value is always positive. Questions to that? Therefore, I know that that function must exist above the x-axis. So I just drew some random graph that is above the x-axis. Question? Please, Bailey. Huh? So I first pick the 3 easy boundaries. 1, 2, 3. Are you familiar with that? Okay, my next thought from there, Bailey, is that I'm kind of thinking, okay, what could this whole thing look like? Well, I've got this, this, and this. So maybe the curve is down here. But maybe the curve is up here. Maybe the curve does both. Maybe it's, this kind of a situation. Where the curve is kind of between, like this, or something. So I'm trying to figure out which of those is happening. So my first thought was do something simple. And I noticed that it doesn't matter what value I choose for x. If that x value is between 1 and 2, well, that's a positive number cubed. So is a positive number cubed going to be positive or negative? Positive times 4 would be, plus 2 would be, so I know it's all positive. So that allowed me to say, hey, this is the situation I have. So that's what I drew. Does that help?
Yeah.
Take it for that. Anybody else? Awesome. Okay, now it's just like a problem that was on the last test. You have a picture, you're supposed to look at the picture and come up with an integral for the area. So you simply note that it doesn't matter where you draw a rectangle, every rectangle's top is hitting the curve, and the bottom of every rectangle is hitting y equals 0. So the y coordinate at the top is the curve, the y coordinate at the bottom is 0. So the integral is going to be the y coordinate at the top subtract 0. You want to do that starting at x equal 1, go to x equal 2. Question? Please,
The bottom is not following the x-axis. Specifically, it could have said x equals 5 to 0.
very good. They said perfect. They said the x-axis, but the x-axis is y equals 0. Every y coordinate on the x-axis is y equals 0. Question? Awesome. So for Ellie. Okay, give me 1 or 2 if the setup makes sense to you. If it's 2, please show me 2. 1 or 2 if the setup makes sense. Sarah, please.
So to find the y values of the points on the graph, you just plug it in the equation. But then, okay, so for this problem, I was thinking that you like set things equal to each other or something.
Gotcha.
Is that why am I?
You're okay. What you're remembering is that on some problems where they only give you 2 boundaries, that means you've got 2 curves. The only way those curves can surround an area is if those 2 curves intersect.
Oh, okay.
So you're remembering a problem where there'd be 1 curve and then another, and they've got to somehow cross. This one's just different. Instead of giving you 2 boundaries, they gave you 4.
Oh, so you don't have to do this.
So you don't have to look for that.
Okay.
Does that make sense?
Yeah.
Good question. Take it. Anybody else? Awesome. So now it's time to do the integral. So now it's, take the anti. This is actually your question again. Again, because the bar applies to both, I had to put the parentheses.
So like, even if the parentheses was like outside the bar, but it was still before like the x to the 4th, it would only apply to 2x.
Yes. Perfect. Yeah, perfect. Anybody else? Take it for time. Okay. I find again, it's just like the last one. 4 is a constant, so I just wrote it down. Then the antiderivative of x to the 3rd is x to the 4th over 4. The antiderivative of 2 is 2x. Plug in the values. Do the arithmetic. The area is 17. I can talk about any detail here that you want. Just ask. Please, Justin.
What's your reasoning for distributing the negative? Like, is that something we should do?
Oh, great comment. I almost always do that because this one didn't really matter. Because all 4 terms are nice whole numbers, so they're easy to combine. But it's fairly common on an integral that you're doing without a calculator for some of these to be fractions. And because they come from a single formula, what happens a lot of the time is this fraction will combine easily with this fraction. And this one will combine easily with this one. So I distribute first so I can make those easier combinations. That's all. I find it harder to combine these two in the end. Is that what you mean? Perfect question, Tiffany. Anything else? You wouldn't have it need more time here, just wave at me. You have a different question. Please, Brady.
Can you go over to 65?
65? I want to do 65 as a class, which means I want a lot of choral response, like group response. So I want to hear your voice, like everybody's voice. So look at me, come on. We're supposed to do this integral, we have to start with antiderivative. So just say yes or no, please. The first thought is, do I have a formula for finding this antiderivative? Please say yes or no. Let's try that again. Do I have a formula for this antiderivative? Please say yes or no.
No.
Louder? No. Good. I want to keep you together on this one. So my next thought is use substitution. Well, I think I can see two functions being multiplied. Please say yes or no if you see two functions multiplied. Come on, say it.
Yes.
Louder.
Yes.
Bailey, please.
I have a question on the other one. When there was like x squared plus 1 on top, you just made it so the 1 was 1x. Can you just not do that since there's an x on the bottom also?
Sorry, I couldn't quite hear you. Say it one more time.
So on the last one, it was like x squared plus 1, and then you just made the plus 1 1x when you did the derivative.
Which number are you looking at? Talk to your point.
I think 23.
23.
Or 24.
You have a good question. I'm just not seeing it.
Plus 2.
Hold on, dude. This is my bad, not yours. Say it again.
So, you did, like when you're doing the antiderivative, you made it so the 4x cubed plus 2 was 4x to the 4th over 4 plus 2x. So I'm just wondering why you can't make the 1 on the other one a 1x. I'm the plus.
This is totally my bad. Say it one more time. It's really me. It's not you. It's
Yeah,
me.
it's the 2x. Like, see how you're adding, yeah, there's a 2 right there. And then you made it a 2x when you did the derivative.
Antiderivative.
The antiderivative. So then all the we're doing right now is plus 1, so why can't you just make
Gotcha.
it?
Sorry. Totally my bad. 2 tickets for Bailey. The difference, Bailey, is in 24, the two terms we're trying to find the antiderivative of are just being added. Here we have two terms being added, but then they're also being divided by x. So I can't split it up like that. Great question. So I'm going to try use substitution. I first must see that there are two functions being multiplied. Please.
Oh, it is. I was just kidding.
You're good. So two functions multiplied, yes? Good. Okay, one function is something to the first. The other function is 1 over something. So my choices for you are the ones in blue. Give me 1 or 2 if that makes perfect sense so far. Come on. 1 or 2 if that makes perfect sense so far. Then my choices for you are what I'm showing here in blue. Take it for the room. Mark it. This choice never works, so skip that. Time for some yes or no questions. Watch. I look at my choice of u. I take the derivative. Actually, I want you to say the derivative. Say it. What's the derivative of this? Say it. 2x. Okay, that derivative is supposed to be exactly the same as the other multiplying function. So I look here. Is 2x the same as 1 over x? Say yes or no. No. Another question. So u sub in that case doesn't work. So just to be sure, just to kind of illustrate an idea, I tried something else. I went from the red to the green. Give me 1 or 2 if you can see how I got from the red to the green. Come on, 1 means yes, 2 means no. You can see that I went from red to green, mathematically, legally, red to green. Take it for the room. Okay, the trouble is I'm not really helping because I still have x squared plus 1 to the first and x to the negative 1. So my choices for you didn't change.
Mr. Louder.
This is Mr. Smith's room.
Oh, she's
Whatever. I think they realized it before they even heard the response. Questions? Cool. So use substitution's a dead end. It's just not working. So your next choice is algebra. So what I recognized is that this can be written as two fractions being added. So give me 1 or 2 if you clearly understand. If you don't, show me 2. And this can become this. 1 or 2, come on. This is the same as this. 1 or 2. So we got a few 2's. All I did was recognize that if I were to add these two fractions, the way fractions add is the denominator stays the same. So the x wouldn't change, but the numerator is just add. X squared plus 1 over x. Why did I put 1? Oh, it's right there, sorry. This one. So these are the same. These are the same as well, just written differently. So these add to become x squared plus 1 over x. Give me 1 or 2 if that makes sense. This becomes x squared plus 1 over x, which is what I started with. 1 or 2, come on, show me. 1 or 2. Talk to me. Let me write it over here, it might be easier to see. Because your eyes trying to jump from here to here. So if we were to add these two fractions, Haley, take it for Haley, the denominator doesn't change. That's how fractions add. So this would be x. And then you do add the numerators. So you have x squared plus 1. So do we have the same thing that we began with in this problem? Yeah, so I can split this into two fractions. I hit a hand in the back. Please. Sarah.
But you're going from, I'm just having a hard time going from multiplying to adding.
It's true. I really am going from multiplying back to division to adding.
Okay.
See it? The reason it's helpful is because this can be rewritten like this. And now I just have two things being added, so I can find the antiderivative of each piece separately. So the antiderivative of x is x squared over 2. The antiderivative of 1 over x is just the natural log of x. Okay, time for questions, because I got puzzle books. Landon, please.
I'm getting confused from like the first red step to the second red step. Yes.
Here to here?
Yeah. Oh, wait, okay. Okay, never mind.
No, you're good. It's good to ask. When you ask, your brain sorts it out. It's
Yeah,
very
yeah.
fun. Yeah, please, Justin.
I'm still a little lost in the substitution because the derivative of x squared plus 1 is x. It's 2x, but and so when I see the x to the negative first, I would think that would work.
Gotcha. It's close, it's just not quite. Because the match has to be with the whole multiplying function,
Okay.
not just the something. That's why I didn't work.
So you can't pull the constant out.
No, you can't pull anything out because there's no constant.
So-
Oh, I know. No, my bad. Sorry. No, watch out. I'll ask you, then you'll see. So what's the derivative of this? Very good. Jackson is correct, and so are you. You can kind of ignore the 2. So you're thinking, hey, the derivative is basically x with the extra 2 there. But x is not the same as x to the minus 1.
Oh, I'm not able to power, that's why.
Yeah, it has to match the whole other multiplying function. It's a great question. Anybody else? So we get to here. Plug in the limit. Let's find the antiderivative. So give me 1 or 2 if you're good to the blue. Come on. 1 or 2 if you're good right here in the blue. Who's good to here? Ellie? Just making sure. There? Take it to the room. Then it's plugging in, so. You have to memorize. Natural log of b is what? What happened to the absolute value bar? Somebody?
It's just
Yeah, e is 2.7-ish, so the absolute value of 2.7 is just 2.7. So the bars don't do anything. The natural log of b is 1. These bars don't do anything either because the absolute value of 1 is just 1. The natural log of 1 is 0. questions? You have a different question about Chin.
Well, I'm just having a mind blank right
You're
now.
good.
Why is the ln of 1 0?
So ln, okay, you gotta hear the words. It's hard to write this down. Okay, ln of 1 is asking you to figure out e raised to some exponent is 1.
Oh.
What's the exponent? 0.
Okay.
So the natural log of 1 is 0.
Okay, that makes sense.
Good, take it. That's why I say it's kind of hard to write that down. But when you see natural log, you think e. When you say e to some exponent, oh yeah, e to the 0 is 1. So the natural log of 1 is 0. You want to have a different question, probably different. 7. Please write this in your notes. If you have not done this problem, please write this down. I'm going to write it in a way that's different. If you write it once, you'll remember it much better in future problems. Please write what I'm writing in your notes. Don't do it on the page. You're going to run out of room way too fast. So I want you to write down that n of t equals number of bacteria. Now I'd like someone to answer this question. What belongs there? Come on. Hand, please. Go. 7,500. Give it for Sydney. Somebody tell me symbolically, what are we seeking in this problem? Like, I don't want to know the words, I want the symbols. What are we seeking, Deborah? Perfect. So we want to know how many bacteria there are at 5. So what symbol will represent? Please sort.
N5.
Nice, n of 5. That's what we're looking for. Okay? I happen to know what n prime of t is. Please tell me what n prime of t is equal to. Go, Attica.
3,002t over that.
Nicely done. And I'm going to write it like this, Annika, because it makes the antiderivative easier. Are you okay with that? Perfect. Take it. Questions, anyone? Awesome. I'm going to use the fundamental theorem of calculus. I don't think I've ever solved a problem by writing it this way, but we've been doing it for a long time, actually. So I'm going to write on the board. Actually, I guess this will be something we've done before. We're going to say n of 5 is equal to n of 0 plus the integral from 0 to 5 of n prime of 2. Give me 1 or 2 if everything on the board makes perfect sense to you. 1 or 2 if everything on the board makes perfect sense. If you sense in the next few days that I have a bit of urgency, it's because I see May 9th approaching much faster than I want. Please.
I don't get the part with it, like the integral part.
No worries. So you say back to me what n prime represents.
N prime is the rate of the bacteria.
Very good. N prime is the rate of change in the bacteria. So what units would be used to describe values of n prime?
The bacteria per day.
Nice. So I'll just kind of abbreviate. So when you're integrating n prime, you're taking bacteria per day and you're multiplying by dt, so days. So the integral gives you what kind of unit?
Bacteria.
Just bacteria. It's actually what we were talking about this morning.
Yeah.
This integral is not going to give you how many bacteria there are. One person, please. What is the integral going to give you, Landon?
The change in bacteria.
The change in bacteria for that time period.
Oh.
Just like the one we did this morning was the change in the mosquitoes for a given time period. Perfect. Combining that with the fact that at time 0 there are 7,500, we'll know how many there are at time 5. Take it. Land as well. Soren, please.
I get that like n of 0 is 7,500 because you start with 7,500, but then because the interval's from 0 to 5, aren't you like kind of counting 0 twice?
Hold a second, I know your question, it's actually very good. Hold on a second. Let me try to see if this helps. If it doesn't, we'll keep talking. The integral really isn't counting 0. It's saying starting at that instant and going forward in time until 5, what would be the change in the number? So it's not including the fact that we already had 7,500. It's saying from that point forward, like you have 7,500, then for the next 5 hours, how many more will grow? So we do have to still combine them with how many there were. I don't know if that's your question.
Yeah.
Okay, take it. Anybody else? Awesome. So can I erase this little unit thing? Now we do this. We say n of 5 is equal to, that's a terrible 5. $7,500 plus 0 to 5, 3,000 e to the 2/5 t. Question? Now it's just a bunch of work. $3,000 is the multiplying constant. Pull it out. Use the antiderivative rule. So we have 7,500 plus 3,000. The antiderivative of e to the ax plus b is 1 over a. E to the ax plus b. Evaluated from, there's Ty's question again. In this case, Ty, I really can put this parenthesis here if I want. Because it's a multiplying constant, it doesn't really matter, it can fit either place. I don't want to put it here though. Good. And in fact, I can actually leave off the parentheses if you want, and then it'll indicate that the parentheses are only applied to this, which is still fine because it's not applied to here. Anybody else? Awesome. So now we get this. Okay, divide by 2/5 is the same as multiplying by 5/2. That's also a multiplying constant, so pull it out. Anyone have a question there? Okay, let's back up, make sure we're all together. So 1 or 2 if everything on the board makes perfect sense to you. Show me 1 or 2. Checking everybody. 1 or 2 if everything on the board makes perfect sense. Please.
I just have a question. If you were to plug in 5 and 0 to the first equation before you did that last step, what did you say was the right answer?
Oh, sure.
Okay, you just
Are you looking here?
Yeah.
Yeah. No, you'll get exactly the same answer. The only reason I do it differently is just from experience I found it to be a little less chance for mistake, to be honest. Yeah. So I just keep pulling out those multiplying constants. Good question, how you took it. 1 or 2 if you're good with what's on the board. Come on, 1 or 2. Who's good with what's on the board? 1 or 2. Hopefully very tall.
So when you have when you try to take the antiderivative of e equals c, how can you use the e, like use the other equation, not the, or how come it's not just e to the x?
Gotcha.
Twice?
You're good. The rules are extremely specific. So one of the rules says that the antiderivative of e to the t is just e to the t. But that only works if it's just t. It can't be 2/5 times t. So the one I'm using is, I have to use the other one. And if I'm using the other one, I have to identify what A is and what B is. So you tell me what's the A and what's the B. A is the 2/5 because it's the coefficient multiplying the t. And what's the B? It's just 0. Because if I put a plus 0, does that change anything? No, so it's really AT plus 0, so I have to use this.
Okay.
Does that help?
Yeah.
Good, take it for grading.
I have a question.
Please, Chad.
So the 1 over 2/5, how did you make that divide? Like, what's the easy way to do that?
So anytime I divide by a fraction, it's the same thing as multiplying by their symbol.
Yeah.
No, good question, take it. No? 1 or 2 again. Hey, who's good on the board? Show me 1 or 2. Who's good on the board? Show me 1 or 2. Good. Landon?
Yeah.
You're good. Take it Pluto. Cool. Wave at me if you need me to keep going, otherwise we'll call it boring at this point. Going? Save a little space here. Hold on. Did I erase the green?
Yeah.
So now I'm up here. 7,500. Hey, look. 3,000 times 5 is 6. 3,000 times 5 is? 15,000. Divided by 2 is? 7,500. Plug in the 5. What's 2/5? Let's write it down. So we got e to the 2/5 times 5 minus e to the 2/5 times 0. A couple of easy ones here. Just say it out loud, please. What's 2/5 times 5? 2/5 multiplied by 5.
2.
Louder. 2/5 times 5. 2.
1.
1. Nice. E to the 0 is 1. Questions to there? Please.
So I just want to make sure, so if the 7,500 are constants and that's why you don't, so like what I did wrong was I did the 7,500 plus 7,500 and then I did e to the second and then I did the whole thing again.
Right. The only mistake was really, okay, the numbers here, because they're multiplying constants that multiply times the value of the integral. So including those was actually okay. It was including this one that was the problem. Because that one was never a part of the integral. You see the difference? Good call. So if you left out that part, the rest would have actually worked. Right, good question. No? So I distribute now. Please, check.
So you did, on your answer, you just wrote equal 7,500 e to the second. Would you not need to put another 5 just because of the order and all the equals that you have leading up to there?
Alexander, you can shoot for that. Yeah, because this left side never stopped being n of 5, it's fine. Please.
So did you only distribute the 7,500 that 2,500 comes out?
Right, because it's basically the same thing as I said in Kelsey. The other 7,500 was never a part of the integral. So it was never being multiplied by anything. It's just off by itself. So the 7,500 here never gets involved. Only this gets distributed. Good question. Okay, cool. May 9th is fast approaching. We are on a very deliberate track at this point. And we just cannot lose time. I've actually slowed down a bit from last year. We got a little bit of ahead in January, so we have a little bit of extra time. So last year the buff sheet was 1 homework assignment, which I made it 2, so that slowed that down a bit. Last year the pink packet was 2 homework assignments, this year 3. You got an extra day on that, which kind of helps. But we have to move on to the yellow now, so.
Like, why can't everything be like, wondering on me, like, is it stop now?
Hey, Lex. Thanks for coming yesterday.
I feel like I know it, I just need to like, I just need to like, get it out of the way. I mean, I guess I've seen everything. Okay.
Once I set a date, I tried to use that. I'm still not done.
Are we learning anything new in this unit, or have we basically So like this unit, have we learned everything?
Oh, gotcha. Hey, quickly, since Chad asked, look at me. Look at me. So we're kind of done with units. What we're doing now is we're 2 more topics, 2 little things to learn today, 1 other thing to learn next time. We're not going to take any more unit tests. The next test I give you will be a practice AP test. It doesn't mean it'll be a full AP test. It will be a portion of an AP test. We talked about how this test would be the only test for term 3. So term 3 is kind of done, even though there's time left, but I just have to manage it this way to help you get ready for May 9th. It's like, okay, to be fair, the school year in this class kind of ends on May 9th. Like, we keep going and we do kind of rigorous academic activities and such, but yeah, you kind of know where I'm headed. So I have to kind of condense things a bit. Like, we got to get it all done before May 9th. So rather than do another unit test, we introduced some topics. Like, we've been mostly focusing on the idea of how to find antiderivatives, how to do integrals without a calculator. Today and next time, today and Friday, kind of new topics, different than that. And then we're going to take a test, a practice test. It will count on term 4. How term 4 works is a little different because you really will take, I don't know how to look it up. It's like 12, 15 practice tests. Okay? Like, everything's a test. And what you have to, and there's no retakes. Okay? Okay, look at me. I'll give you the details later. But what you have to establish is a pattern that shows me that you are properly training for the AP test. There's different ways you can show me that. Like, some people show me by, they start out not too well, but then they show me test after test that they're making progress. Okay, what you can't do is do really, really bad and then just suddenly hope to spring to life at the end. It's like trying to train for a marathon in a week. It's not going to work. You got to train day by day. So I'll explain later, but
When you start to do like the game,
that's when we start the game as well. Not exactly. It may actually be true that we take a practice test in each practice periods. It's treated differently than the test you're used to. So don't panic. I'm not worried about you. You're not. You're on the right track. Hey, look up. New concept. Hey. So look at number 20 in the yellow. Look at number 20 in the brand new concept. Oh yeah. Okay, they're defining a function But the interesting thing is the function is defined in a way that we haven't really used much. It's a function defined using an integral. It's a function defined using an integral. The idea is pretty simple. Okay, I would like to answer this question out loud. Think of 1 over t as being a velocity. So just say it again. If you integrate velocity, what are you finding? Change in position. But you're finding the change in position for a certain time period. In this case, it would be from time equal 1 to some unknown time in the future. Make sense? So that means this function is how you find different changes in position for different time periods. Agree with me? Like if I plug in a 5 here, f of 5 will represent the change in position from time 0 until time 5. Give me 1 or 2 if that makes perfect sense. So f of 5 would simply represent the change in position from time 0 until time equal 5. Take it for the room, please. Oh, sorry, time 1. I said it before. My bad. So from time 1 to time 5. Pretty good? Okay. That's the idea of using an integral to define a function. Okay, the new concept is, now that we can find functions using integrals, we need to be able to find the derivative of those functions. So I'm going to give you a rule that allows you to take the derivative of a function that is defined as an integral. I call the rule the derivative of an integral. Okay, the book calls it the second fundamental theorem of calculus. I like the word derivative of an integral because it describes what you're doing. So write this down, please. D over, okay, we must always differentiate with respect to the input variable. We're differentiating f, because it says up here we're supposed to find f prime. In fact, I should probably fix that, sorry. So we really should write f prime first. So f prime of x is the same thing as the derivative of f. F prime of x is the same thing as the derivative of f. That's not new. Okay, down here it's important. Do I put dx or dt? Dx. Because we're taking the derivative of f, and the input variable for f is an x. So this is dx. You don't look at the t here. We're taking the derivative of f, the input variable for f is x, so this must be dx. 1 or 2 if that makes sense. Come on. Are you good? Take it for the room. Okay. Which means we have to take the derivative of this integral. So we go d over dx of the integral from 1 to x. And before I forget, I'm a little short on class time today because the questions were very good. I'm glad we spent the time on those questions. But because we're a little short on class time, I'm deliberately doing different examples in A1 versus A2 versus A4. And so if you look at my notes online after when today is over, you'll see more examples than what you saw in class to help you with the homework. Okay. To find the derivative of an integral, the pattern is really simple. You simply take the integrand, but instead of writing 1 over t, you replace the variable with the upper limit. So you write 1 over x. Okay, now, I'm going to tell you up front that today, I'm not really going to explain why this rule works. I'm going to show you how to use the rule, but I won't talk about why. We'll kind of do that later. So the how to use it is, I'm supposed to find the derivative of this integral. Step 1, identify the integrand. The integrand means what is being integrated right here. Instead of writing the integrand as is, you just rewrite the integrand plugging in the upper limit. So it became, instead of 1 over t, it's 1 over x. Are we good to there? Okay, good. Then you must multiply by the derivative of that upper limit. So the upper limit ended up in 2 places. It ended up in place of the t, but it also is the derivative of that upper limit. Then you say minus, and you do exactly the same thing for the lower limit. So someone follow those instructions and tell me what to write. How you please?
1 over 1, and then d of x over t.
So Super close. One tiny mistake. One tiny mistake. Go here, Sarah. P of 1. No worries. That makes sense.
Yeah.
You're good. Take it for Sarah and Heidi. That's how you find the derivative of an integral. So the pattern's really simple. Just memorize that pattern.
Can you say the pattern again?
Uh-huh. So all you do, Soren, is grab the integrand, replace the integrand with the upper limit. Sorry, plug in the upper limit into the integrand.
Okay.
So it was 1 over t, so it becomes 1 over x.
Okay.
Multiply by the derivative of that upper limit,
Okay.
minus, same thing with the lower limit.
Okay.
So instead of 1 over t, I write 1 over 1,
Okay.
and then derivative of 1. Good question, ticket. Anyone else? Please, Haley.
I have a question. So is the whole thing like the rule or just the part of the
Gotcha.
maths?
The first part is just notation. They asked us to find f prime, which means they want me to find the derivative of f, which means they want me to find the derivative of this integral. Well, how do I do that? I do this. Take it, anybody else? I now clean it up a little bit. There's some really easy things. What's the louder? That's gone. What's dx over dx? 1.
Fantastic.
Somebody double check the answer in the back, please.
I already did.
Yeah, it is.
Perfect. Question? Awesome. Let's go forward and find one more of those. This will work. So look at 24, okay? Look at 24. It says find capital F prime of x. It means I've got to be finding the derivative of something. Someone raise your hand and tell me what must I write here to indicate what am I finding the derivative of? This is for help. Kelsey. So capital F, perfect. Yeah. And so that must equal, somebody tell me what to write next. Take it for Kelsey. Okay, please. I can't just do the integral because I'm trying to take the derivative of something. So what do I write next? Take it, Storm, go.
Well, couldn't you also just put that equal to f prime of x?
Sure.
On the last one?
Take it for that one. Then what do I write? Ellie. So I write d over dt or dx? dx. And what comes next, Ellie?
And then the integral from 1 to x squared from 1
Take it for Ellie. Please, please.
So you're saying like over dx, but you like keep asking dt or dx. Why is that?
No worries. For our class, we are always going to take the derivative in terms of whatever the input variable is specified to be.
Yeah.
So because they said find f prime of x,
Yeah.
they're telling me the input variable is the x.
Oh, so if it was like f prime of t,
It would have to be
it would
dt.
okay.
Oh, perfect. Does that make sense?
Yeah.
Perfect. Anything else? Cool. So now we just apply the rule. So somebody apply the rule based on the previous example. Nicely done. So 1 second, Deborah. So she takes away the t, puts the upper limit in place of the t, but the t value was being cubed, so she puts a cube here. Keep going, Deborah. Pause right there. If you have a question at that point, take it. Nice, somebody finish it. Deborah's got it, take it. Lexi, please.
We do minus square of 1 plus 1 to the 6, or I mean 1 to the 3rd. And then d1 over 2.
That's done, take it, Lexi. Somebody just clean it up ever so slightly. Heidi, please.
Dx squared over dx, they cancel out, so it's just x.
Oh, ticket, but no, just let me correct you.
Okay.
Yeah, it's not really c times x squared and d times x, which means they would divide.
Yeah.
It's the derivative of x squared. And what you know, what's the derivative of x? 2x. So this becomes 2x. Take a variety, somebody pick it up from there. Just keep cleaning it up. Please.
Square root of 1 plus
X to the what? Good. Somebody else? Bailey?
x. Last part is 0.
Yeah, we're done. That's the derivative of that integral.
So just going back to question 20, if you were to switch it and say instead of 1 over x, it was, or 1 over t, what if it was like t over 2 with the x still switch to t?
Yeah, you're just always taking the integrand and plugging in the upper.
So, I'm sorry. Integral things, right? So, for example, if you're doing velocity, when you're finding the derivative of the integral of velocity, all that equation does is like the equation is, I don't know how to say it, but
I don't know how to say it either.
a constant to any number and finding the I don't know how to say it.
Let's don't worry about that, to be honest, because you're delving into an area that is not tested on this task, and it gets hard to explain it. But I'm with you as far as what you're thinking, because the integral is going to find me the change in position. It means the derivative is going to be the rate at which the change in position changes. They don't ever go that far. Is that okay? Yeah, for this class, as far as they go, is they do give problems where you have to find the derivative of integrals, but they don't have stories. Okay. So, good question. Next new thing. Pretty good? Okay, another new thing today. Go to 19, please. 19. Okay, it's a limit problem, and today we're going to learn a new tool for solving limit problems. Okay, I'm going to write down the name. You don't have to know the name. However, I'll refer to the name a lot, so it helps to have seen it. If you speak French, it means the hospital. And it's the guy's name, I don't know what his first name is. His last name is Mofital, is how you say that? In the hospital, I don't know. I've seen it spelled like this as well. Okay, Mofital's rule. Okay, rather than show you the like the strict mathematical way a textbook would illustrate the rule, it's typically a lot easier to do it in kind of a common sense way. Okay. So the way you use L'Hopital's rule is if you need to find a limit, you first do a little test to see if this rule will work. So step number 1, write a 1 down, please. Okay, the test is to plug in whatever the limiting value is. So in this case, the limiting value is x approaches pi over 4. If it were x approaching 0, we plug in 0. If it were h approaching 3, we plug in h equal 3. If it were y approaching 2, we plug in y equal 2. You just plug in whatever the limiting value is. Good? So let's write down what happens when we do that. Again, the different examples in the different periods, so you get lots of examples in the notes today. So you have the sine of pi over 4, excuse me, subtract pi over 4. All divided by pi over 4, subtract pi over 4. That's the test. Just plug it in. It's not the typical way we find limits, but it works really well with L'Hopital's rule. Pretty good there? Now it gets really easy. I'd like you to answer as a class. What's pi over 4 minus pi over 4? 0. You may have forgotten that the sign of 0 is 0. Okay? Divided by 0.
0.
No, 0 divided by 0 is called indeterminate. Like we don't know. Okay?
Sweet.
But that's good news because with L'Hopital's rule, you do the test, you get an indeterminate form. Write this down, please.
Yeah, I have shared that on
Indeterminate. So if you do the test and you get 0 over 0, or maybe you get infinity divided by negative infinity, or perhaps you get infinity divided by infinity, or maybe you get negative infinity divided by positive infinity, or maybe you get negative infinity divided by negative infinity. No, so it's either 0 over 0 or infinity divided by infinity where the signs don't matter. So if you get one of those cases, the test passes, which is good news. It means L'Hopital's rule will work, or at least may work. So the test passes. So step number 2 is to find the derivative of the numerator of the expression we're trying to find the limit of. So we go up here. Step number 2, we take the derivative in terms of the limiting variable, so in terms of x, of the numerator. We're not using the quotient rule, we're just taking the derivative of the numerator. So write that down, please. You're just taking the derivative of the numerator. Please.
So we plug in pi over 4 because that's the limiting.
Right, so you always plug in the limiting value. That's the test. If the test succeeds, you'll get 0 over 0 or infinity over infinity, where plus and minus don't matter. Okay, this derivative is really,
What does that mean, though? Like, if we're
yeah, so again, same thing, apologize, lack of time. I can't really give you the theoretical background on why this works. All I can do is give you the procedure. Apologize on that. I appreciate that. Really? Yeah, sorry.
If it's not one of those forms, then you just stop it.
Then you got to use a different method for finding the limit. The good news is, on our AP test, it almost always works. Almost is the worst thing you always look at right now. Good news is that 63% is a 5, so almost is pretty good.
Yes.
Hey. Hey, roughly, it goes a little bit. Hey, watch, come on, gotta hurry a little bit, gotta hurry. Look up, look up, look up. So the derivative of the sine is the cosine. So this is equal to the cosine of something multiplied by the derivative of that something. Questions? Please, Soren.
So you only take the derivative of the numerator. Okay.
Say it out loud, please. What's this derivative going to be? 1. Does anyone have a question? Because there are two things separated by addition. The derivative of pi over 4 would be 0, and then dx over dx is 1. So the derivative of the numerator is just the cosine of x subtract pi over 4. I got the extra dot there. I got to fix that. Okay, give me a 1 or a 2. If everything, like I know I haven't explained why it's working, but if you're good with the procedure so far, give me 1. If you're not, give me 2. Whatever, please.
Why did you put pi over 4?
I have no idea.
Oh, yeah.
Good question. Take it. Hey, show me, come on. 1 or 2 if you're good at the procedure. 1 or 2, show me, come on. Chad, what do you got? Good. 1 or 2 if you're good at the procedure. Sarah, you good?
Oh, yes.
Please, great, good, awesome. Okay, step 3. It's, no, comment on Landon's comment, I get that. Hey, listen, hey, Landon, everybody else. The first time through L'Hopital's rule, it feels like a lot of steps. Once you see the rule, you're like, oh, this is easy to remember, it's easy to do. Because all I do is test by plugging in the limiting value, and then it's simply derivative of numerator, derivative of denominator. So I take d over dx, and you're always taking the derivative in terms of the limiting variable. So d over dx of x minus pi over 4. That derivative is pretty darn easy. 1. Step number 4, you create a new limit problem.
We can do that.
L'Hopital's rule says we can. And the new limit problem is simply the 2 derivatives divided by each other. So we take the cosine of pi over 4, sorry, the cosine of x subtract pi over 4. That's the numerator derivative divided by the denominator derivative of 1. So you create a new limit problem. Write it down. Please, Bailey.
So for the first step, did you just do the derivative of what's in the parentheses of the cosine?
Correct. But actually, it wasn't really doing that. Sorry. Step 3 was to take the derivative of the denominator. And because the denominator is x minus pi over 4, that's the derivative I want. That was coincidence that it matched up. Good question. Anyone else? Come on, stay with me.
Is it like on problem 3 is supposed to equal 1 every time, or just this one?
The denominator derivative, or it's common that it does, but it doesn't have to. For our class, it's common, it doesn't have to. So don't assume that they'll fool you, of course. Hey, so we good here? So we have a new limit problem. You just do the test again. Yeah, I'm not explaining the why. This is just how the procedure works.
How many times?
It's honestly, you just keep doing it until you get a number.
This is a lot better than Yo, so there's not like a specific amount of times?
For our class, usually once is enough. But you just, if you get an indeterminate form again, you just do it all again. So for many for many limit problems, it's better to use other methods. But for this limit problem, other methods are not very useful.
How long are you getting the number like on step 3?
No, it's when you test. When you test.
Oh, so you really have to look and then
Indeterminate.
and what is it
Bad
that
number.
you get?
That's why I say the procedure actually is really pretty straightforward what you can do. So hey, test again. Come on. So I take the cosine, plug in pi over 4, that's the limiting value. Divide by 1. Okay, you're going to get the cosine of 0. You may have forgotten, but the cosine of 0 is equal to 1. 1 divided by 1 is 1, that's the limit. Check the answer for me, Landon. Wait, go back there. Jackson, please.
So the sine of 0 is 0, but the cosine of 0 is 1.
Yeah, we need to review the unit circle again.
Oh, it's a unit circle. Okay, that makes sense.
Oh, that makes it easy.
We'll wait for the morning to see. Set it at another week. Glad you said the right answer. Yes. Okay, we're going to do one more. Look up, come on. Look up. Questions? Hey, please. See you.
So
Her mind is gone. She opened there's powers in the fish. Overwhelmed.
She got like her face was like slow. She got like a little chunk of skin.
That's my joke.
It's not a big chunk.
You know what talk? He's got pretty great silence again. Silence. Ready. Okay. Sarah's question is this. Look at me. Hey. It's a limit problem. The methods we learned to do limits, like we haven't done this since test 3 at Christmas, there were some limit questions. Okay. To find the value of a limit, one thing we've always done is look to factor. But this doesn't factor, so that's not going to help. Another thing we've done to find the value of limits is we just plug in numbers that are close on either side. That doesn't work in this case because you just keep getting like 0 over 0. So that's why L'Hopital's rule is the only way to do it. So we used to use the rule. Please.
So if L'Hopital's rule doesn't work and you can't use any other ones,
Then it's not this class problem.
okay.
To be honest.
Okay.
Then it's quick.
So for the level of difficulty that we are preparing for, that's not going to really come out.
Okay.
Let's do one more, we got time. So here we go. A reminder, hey, we gotta go a little quick, watch everything. Sine squared of theta really means the sine of theta squared. Sine squared of theta really means the sine of theta squared. Question? Sine, you've learned this before, it's not new. Sine squared of theta really means the sine of theta squared. Okay? So L'Hopital's rule says, test, first thing, test. Plug in the limiting value. Okay, we discussed this a minute ago. The cosine of 0 is equal to, say it, 1.
1.
And then we plug it on the bottom. The sine of 0 is equal to 0. So what's the numerator equal to? 0. What's the denominator equal to? 0. So did the test pass or fail? Pass. So we try L'Hopital's rule now. Question? So that means we take the derivative of the numerator and we take the derivative of the denominator. So here we go, step number 2, derivative of the numerator. So I take the derivative of 1 minus the cosine of theta. I'll finish this, so it'll be in the notes. Okay, it's got to be in terms of the limiting variable, which in this case is theta. The derivative of 1 is 0. The derivative of the cosine is the negative sign, but because that's negative, it becomes positive sign. So this derivative is equal to the positive sine of theta. Step number 3, take the derivative of the denominator. 2 sine of theta
Please come to
squared.
the main office. Bethany
Over to
Jackson, Haley Hyde, Adrian Story.
So that's equal to,
Again, can I
2 is a
please have
multiplying
Bethany Jackson,
constant.
Haley Hyde, and
This
Adrian
is
Story to
something
the
to
main
remember,
office?
so
Thank
let's bring down
you.
the 2, multiply by the something, raised to the new exponent, which would be 1, multiply by the derivative of that something. So that's equal to 4 sine of theta cosine of theta. Questions? Please.
Why is it 2 times 2?
The 2 is an extra multiplying constant, so I just wrote it down. Now I've got something to a number. Find the derivative, bring down the 2. Good question. Anyone else? So we have the numerator and denominator. Step 4, we create a new limit problem. Come back up here. The new limit problem is the limit as theta approaches 0 of the sine of theta divided by 4 sine theta cosine theta. Something nice just happened. What can you do with that?
Sine theta finds out.
The sine of theta can divide to make 1. So you get another limit problem that looks like this. 1 divided by 4 cosine
For your
theta.
person, please come down to the attendance office
Test
for
again.
checkout. For your person, please come down to the attendance office for checkout. Thank you.
I think I lost step 4 somewhere. The test again, because I just did the two derivatives together. Cosine of 0 is equal to what? 1. The answer is 1/4. Good work.
I'll see you.
Historically, year after year, what you learn is
Oh, dang! She's over What? I heard that. No, I was perfecting. Right? Thanks, dude. Defending on what?
Okay.
Do you have work on Saturday?
Trashing on me like usual?
I don't listen to the
It's easy to pull out right now. This is important. Thank you.
So just think about negative 1. Good job, Ellen. Log of 2 is divided.
It has to be doing with breaks, Joe. Now we do it strawberries. I have a lot of questions. Oh, you did a lot of music class?
Yeah. You know the other way around.
That sounds good. It is.
No, I don't want to do that. Sorry. Do I say something? So what I do instead is
So you end up with
negative.
Thank you, Mrs.
You're welcome.
Thank you.
You're welcome. So that becomes negative 1 times the natural log of 1 subtract the natural log of 2. What's the natural log of 1?
Okay. That is like.
Yeah, that's why I actually agree with them. I hope they don't test on that anymore, because I'm not sure the value of it. Like it's a little puzzle to try to figure out how the heck to get that answer.
Yeah.
But your answer is just as valid.
That took us because we got this and then we're like, none of these.
Sorry.
And then I plugged it into the calculator because we both had the same value, and I was like, how does that work? And then I'm trying to figure out like negative exponent and how it would work. It's like,
That makes sense.
yeah. I miss for class so much. I want to go back to Cal.
Thanks. Good job, you guys.
Bye.
See ya.
Well, good. We're not crazy.
Good morning, Matt. This is Fred Bromley. And ceremony students, please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice. Thank you.
Student council packets are available in the main office. If you are interested in running for student council, come get a packet.